In this lesson, we shall discuss substitution rules. Let us begin our discussion with substitution rule for powers. Let g be a differentiable function in x and n a rational number not equal to -1. Our indefinite integral for g of x raised to n times g prime of x dx is equal to g of x quantity raised to n plus 1 all over n plus 1 plus c, and the substitution process involves letting u be equal to g of x and that du is equal to g prime of x dx. Our substituted form now becomes integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c. Note that u here is the base of the power. For our first example, let us find the indefinite integral of 2x plus 7 times x squared plus 7x plus 3 raised to 15 dx. So here we let u be the base. So we have x squared plus 7x plus 3, and then du is equal to 2x plus 7 times dx. So for substitution rule for powers to work, we need to be able to express our given to the form u to the n du. So this base here is going to be replaced by u, and then notice that du is also found in our given. So we have 2x plus 7 dx together will be our du. Thus, we can convert our given to the form u raised to 15 du. And to solve this, we have u raised to 15 plus 1 or u raised to 16 over 16 plus c. And then performing back substitution, we replace u with x squared plus 7, x plus 3, and then we have raised to 16 all over 16 plus c. So this is our indefinite integral. For our next example, let us find the indefinite integral of 4y cubed times the fifth root of the quantity y to the fourth minus 8 raised to 3 dy. So first, let us transform our given into the power form. So this is equivalent to 4y cubed times the quantity y raised to 4 minus 8. So this is raised to 3 over 5, and then we have dy. Now, let us check whether substitution rule for powers will work for this given. So we let u be the base. So this is y raised to 4 minus 8. And then du is equal to 4y cubed dy. So observe that our base will be transformed into u, while 4y cubed dy together will form our du. So therefore, our given can be written as u raised to 3 over 5, and then 4y cubed dy is equal to du. Integrating, we have u raised to 3 over 5 plus 1. So that would be u raised to 8 over 5. And then over 8 over 5 plus c. We get the reciprocal of 8 over 5. So this becomes 5 over 8. U raised to 8 over 5 plus c. And then we perform back substitution. We have 5 over 8. We replace u by y raised to 4 minus 8. This is raised to 8 over 5 plus c. So this is our indefinite integral. For our next example, we find the indefinite integral of 6x plus 1 all over 3x squared plus x minus 1 raised to 2 dx. So here we let u be 3x squared plus x minus 1, and then du is equal to 6x plus 1 times dx. So if we perform the substitution, our given becomes, so 6x plus 1 dx together, this will be our du, and then for the denominator, you have 3x squared plus x minus 1 will be replaced by u, and then we have raised to 2. Rewriting this, we get u raised to negative 2 du, and our indefinite integral is u raised to negative 2 plus 1, so that is negative 1 over negative 1 plus c. So this is the same as negative 1 over u plus c, and then Back substitution, we have negative 1 over 3x squared plus x minus 1 and then plus c. For example 4, we have find the indefinite integral of 16x over the square root of 1 plus 2x squared dx. So let us first transform our given. So this is equal to 16x times the quantity 1 plus 2x squared raised to negative 1 half dx. Now we let u be the base, so that is 1 plus 2x squared. And then differentiating this, we get du is equal to 4x dx. Now, to perform the substitution, our base will be changed into u. So that would be u raised to negative 1 half. However, based on our substitution, du is equal to 4x dx. Now, in our given, what we have is 16x dx. So what we could do here is, since 16 may be factored as 4 times 4, 4 times 4, so we have 4 times 4x, and then you have 1 plus 2x squared raised to negative 1 half dx. So since we need 4x dx to become our du, and 4, the other 4, we could just factor this. So we have 4 times 4x dx will now be replaced by du, while the base 1 plus 2x squared will be replaced by u, and then we have raised to negative 1 half. Therefore, we can now solve this as 4 times u raised to negative 1 half plus 1, so that would be 1 half over 1 half plus c, and then simplifying, multiplying 4 with the reciprocal of 1 half, so this gives us 8 times u raised to 1 half plus c. Now we perform back substitution. We replace u by 1 plus 2x squared and then raised to 1 half plus c. We can also write this as 8 times the square root of 1 plus 2x squared and then plus c. Example 5, we have indefinite integral of t squared over t cubed plus 4 raised to 10 dt. So this is the same as t squared times t cubed plus 4 raised to negative 10 dt. So here we let u be the base, so this is t cubed plus 4, and then du is 3t squared dt. Now observe that in our given, so we're going to let our base to be u. However, we only have t squared dt in the given, whereas in our substitution, we need 3t squared dt. So what we could do is we could introduce a correction factor so that we can perform the substitution. So we need to put 3 in our given. However, we need to correct that by putting a correction factor outside the integration symbol. So we need to put here the reciprocal of the number we placed inside. So that would be 1/3. So that when we perform the substitution, our given becomes 1 over 3 times the integral of. So our base t cubed plus 4 will now be changed into u. We have negative 10. And then 3t squared dt together will now become our du. Therefore, we can solve this now as 1/3 u raised to negative 10 plus 1, so that is negative 9 over negative 9 plus c. And then simplifying, we have a negative 1 over 27. So u raised to negative 9, we could just put that in the denominator. So you have 1 over u raised to 9 plus c. And we perform back substitution. So this is negative 1 over 27. We replace u with 3t cubed plus 4. So this is raised to 9 plus c. In solving integrals involving substitution rule for powers, there might be instances wherein the base is a transcendental function. Just like in example 6, here we let u be cosine x. So this is trigonometric. And then we know that its derivative is negative sine x dx. Now, if we perform the substitution, u will be cosine x. So this will become u raised to 4. However, our given contains sine x dx, whereas in our substitution we have negative sine x dx. So what we could do is we could introduce again negative 1 in the given, and to correct this we put a negative sign outside, or we put negative 1 outside. Thus our given becomes, or in substituted form, we have negative times negative 1 times the integral of u to the fourth. So negative sine x dx will now become du. And so the integral will be negative u raised to 5 over 5 plus c. And then performing back substitution, we have negative 1 over 5. We replace u by cosine x. So this is raised to 5 and then plus c. For example 7, we have indefinite integral of cotangent x raised to 7 times cosecant x raised to 2 dx. So here we let u be cotangent x, and its du is equal to negative cosecant squared x dx. Now for the substitution to work, we need to have a negative cosecant squared x dx in our given. And observe that we only have cosecant squared x dx. Thus, we multiply our integrand by negative 1, and we correct that by putting a correction factor of negative 1 outside the integration sign. Thus, our given becomes negative of the integral of negative cotangent x raised to 7 cosecant squared x dx. And performing the substitution, we will be replacing cotangent x by u and then raised to 7. Now negative 1 together with cosecant squared x and then dx will all become du as shown in our substitution. And then solving this, we have negative u raised to 8 over 8 plus c, and this is just the same as negative 1 over 8. Replace u by our original base of cotangent x. So this is raised to 8 plus c. For problem 8, we are going to evaluate the indefinite integral of 2 ln y over 3y dy. So first, what we could do is we factor 2/3, and then we'll have integral of ln y over y dy. So here we let u be ln of y. So again, we have a base that is a transcendental function, specifically logarithmic function. Then du is 1 over y, and then we put dy. Thus, if we perform the substitution, we have 2/3. So we replace ln of y by u, and observe that dy over y, so dy over y is our du. So therefore, its integral now will be u squared over 2 plus c, and then simplifying, we can cancel 2, and we are left with 1/3. We can also now replace u by ln of y, and then raised to 2 plus c. Next, we have indefinite integral of the square root of arctangent of 1 minus x over x squared minus 2x plus 2 and then dx. So let us first rewrite this as arctangent of 1 minus x. So this is raised to 1/2 all over x squared minus 2x plus 2 dx. Now we let u be arctan or arctangent of 1 minus x, and then du is equal to, so using the formula for inverse trigonometric function, so this is 1 over 1 plus 1 minus x quantity squared times the derivative of 1 minus x, which is negative 1, and then we put dx. So this is the same as negative dx over 1 plus, so let us expand 1 minus x raised to 2. So this gives us 1 minus 2x plus x squared. And this is the same as negative dx over x squared minus 2x plus 2. Now, let us observe our given and check whether the substitution rule will work. So arctangent of 1 minus x will be replaced by u. So that would be raised to 1 half all over. Now dx over x squared minus 2x plus 2 is du, but we need to put in a negative 1 so that the given, we can perform the substitution. So we put negative 1 inside and correct that by putting negative 1 outside as well. So thus our given becomes, or in substituted form, we have negative of the integral of u raised to 1 half and then du. So let's just erase this one, so that the integral now is negative u raised to 1 half plus 1. So that is 3 over 2 over 3 over 2, and then plus c. Getting its reciprocal, we have negative 2/3. Let us also replace u with our base. So this is arctangent of 1 minus x, and then we have raised to 3 over 2 plus c. Next, we have integral of secant squared of 4 theta times tangent of 4 theta d theta. So here we're going to let u be tangent of 4 theta, and then we have du is equal to secant squared of 4 theta times the derivative of 4 theta, which is 4, and then we put d theta. Now, let us show the substitution. So we have tangent of 4 theta will become u, and then secant squared 4 theta d theta. So for substitution rule to work, we need to have a 4 inside our integration symbol. So we need to put 4 here and then correct that by putting 1 over 4 outside. So this becomes 1 over 4. We now have u times 4 secant squared 4 theta d theta altogether will become du. And so the integral will be 1 over 4 u squared over 2 plus c. And this is the same as 1 over 8. We replace u by tangent of 4 theta and then raised to 2 plus c. So an alternative solution for this problem will be, so let me just rewrite the given. So this is secant squared of 4 theta, tangent 4 theta d theta. So this is the same as secant of 4 theta, secant of 4 theta, tangent of 4 theta d theta. So we are going to let u be secant of 4 theta, and we know that du is equal to secant of 4 theta tangent of 4 theta times 4 d theta. So again, we need to put 4 inside and correct that by putting 1 over 4 outside. And then this becomes 1 over 4. Secant theta will become u. Now 4 together with secant 4 theta tangent 4 theta d theta will all become du. And so our answer will be 1 over 4 u squared over 2 plus c, and this is the same as 1 over 8. We replace tangent, or we replace u rather, with secant of 4 theta raised to 2 and then plus c. Next, we have integral of cosinh 3x dx over sinh of 3x raised to 5. Here, we let u be sinh of 3x. Then we have du is 3 cosinh 3x dx. We put 3 inside our integration sign, and we correct that by putting its reciprocal 1/3 outside of the integration sign. We now have 1/3. Substituting, we have 3 cosine 3x dx will now become du, and then we have sinh of 3x will be replaced by u, and then raised to 5. Transforming, we have u, or 1/3 times the integral of u raised to negative 5 du, and this is 1/3 u raised to negative 4 over negative 4 plus c, and this is the same as negative 1 over 12 u raised to 4 plus c, and then back substitution, we have negative 1 over 12. We replace u by sinh of 3x, and then put 4 plus c. Lastly, we have integral of the quantity e to the x plus 4 raised to 3 times e to the x dx. Now here, our u is the exponential function e to the x plus 4. Now du is e to the x dx. And let us see whether the substitution rule will work. So we can replace e to the x plus 4 by u raised to 3, and then e to the x dx will be replaced by du. So since we are able to convert our given to the power form, we can now solve this. We have u raised to 4 over 4 plus c, and then we perform back substitution. We have 1 over 4. U will be replaced by e raised to x plus 4 raised to 4 plus c.